Welcome everyone to the topic of program risk management control video. So, risk management overview, what are we looking into it? Establishing a risk review board, the RRB, risk review board, led by our project managers, and it should be meeting on a monthly basis. Includes representative from each of the functional and support areas per se. Let me talk about software as an example, hardware as an example, test as an example, quality assurance as an example, configuration management as an example. Now I've given you an example for a software project management. What are the various intra-departmental that needs to be taken care of? Process should be and always would be iterative. Documented feedback to both project management and the customer thereby. So risk management, if you see the onogram, the risk management is all about risk planning, is all about risk assessment, is all about handling risk and monitoring risk thereby. Based upon it, you will be talking about risk identification analysis and giving a feedback. The assessment will deal around here. So this is nothing but risk documentation that will needs to be kept and should be indexed altogether, because this is where you need to refer if things goes wrong, where was the problem all about it. So risk management, all risks are documented. This includes a short description of the risk type, schedule, cost, technical. The severity is all about low, being moderate or high. Risk mitigation plan, the status of the risk mitigation activities. Metrics must be used to measure the effect of risk and to identify if it is needed, indeed occurring. Everyone on the project is encouraged to identify risk during any management or technical meeting. Never overshoot the messenger. Once a risk is been identified, a risk mitigation plan created, it is assigned to a responsible person. Risks are monitored. Risk and plans are to be updated until the risk is reduced to an acceptable level or manageable position. Read the article by Conroy and Sistudo to find out how specific risk issues were dealt with the TRDW project. Putting risk management into practices, if I may say so, it is a well reading and talking about risk management. But what happens when you yourself are responsible for it? Where can you find a tried and tested risk management plan? How do you put what you read into practices? How do you identify the risk you are exposed to? Which strategies work well, which don't? Risk management must be a continuous activity throughout the project. Everybody must be involved in risk management and mitigation. If it is to work, the customers and the supplier must continuously and independently manage their own risk. Some risk can be managed jointly. Let us look at sponsorship. For risk manager to succeed, there has to be a commitment from the suitably a powerful individual, typically the customer project manager. The sponsor must be visibly involved in the project lifecycle everywhere. Often, all the customer needs to do is to ask the latest status on the identified risk on a regular basis. The focus activities, generate a list of risk statements, evaluate them for probabilities and impact, classify them and rank them in priority order, develop mitigation strategies for them. Remember that there is no point spending having 5 people spend 2 days developing a mitigation strategies for identified risks that has probably low probabilities, low priority, and in fact no impact maybe. That is less than 10 days delays to the schedule in these cases. Do not spend more time. Do not even spend any money managing the risk. What the cost of the risk is more than the cost of the risk actually is. Document all risk. Remember, it is harder to ignore if it is written down. I'll give you hints. Document every risk, be precise. Vague wording is as ineffective as it can be. Evaluate the likelihood of the risk, estimate satisfactory. Identify the impact of risk, its consequences. Quick and dirty estimates, high, medium, low, is typically sufficient. Assign the risk to an individual. Make all risk visible to everyone. Track and monitor all risks. Classify or group risk. Different people will see different aspects of the same risk. Project managers, configuration managers, software engineers. Prioritize risk and reevaluate periodically. Remember, you cannot, I repeat, you cannot fix everything. Not every risk can be mitigated. Every condition has a number of possible outcomes, consequences I'm talking of. And each will create a risk that could be mitigated. Identify the critical risk and watch them for a significant changes. Identify the risks that can be accepted. You can live with them or if they occur. Identify the risks that are better managed by someone else. Track the risk, monitor them. How else do you know what has going wrong? Metrics is the answer. Measure, indicators, and triggers can help you watch for the significant changes, giving you certain more hints to help you out. Are you sure you can close the risk? Closing a risk because you can took an action. Any action is not controlling the risk. It is probably allocating to it. Controlling a risk means altering mitigation strategies when they become ineffective. Taking action on a risk that becomes important enough to require mitigation. Taking a pre-planned contingency action. Dropping to a watch only mode at some specific threshold. Closing the risk when it no longer exists. Check to make sure that your action reduces or manages the risk thereby. Let us try and understand what estimating would be. When bidding for a contract, we need to make several estimates in order to determine schedule, cost, etc. Estimate uncertainty occurs because an estimate is probabilistic assessment of future condition. Estimator produces an estimate based on estimation model. This model itself can be a source of error. Measurement error. This occurs if some of the input value into a model have an inherent accuracy limitation. For example, function points are assumed to be 12% inaccurate. Therefore, a project with an estimation of 1000 function points could end up anywhere between 880 to 1120 function points in reality. That's just a 12% variances. Applying a model of 0.2% days per function point means your estimate will have a range of 176 to 224% days, with the most likelihood values of 200% days per se. There is a model error. All empirical models are abstractions of reality. Remember, that's a very true fact. No model includes all the factors that can affect the final outcome because it is simply not possible. Factors not explicitly included in the model contributes to the model error. For example, a model of 0.2% days per function point is usually obtained from the result previously observed. It is unlikely that the future project will achieve exactly the same ratio, but it is expected that the model is all right on average. If an estimation model with an inherent 20% inaccuracy, your project is of 1000 function point, then your estimate is likely between 160 to 240 percentage. Errors are additive. Once a small thing goes wrong, it can only go and go bigger and bigger. Estimate error and model error are additive. The real range of values is between 140.8 to 268.8 percentage, with the most likelihood value of 200 percentage. Using the mean magnitude of a relative error to assess model accuracy can be misleading. There is no priori reasons for underestimations and overestimations to be of equal size. Underestimation is a naturally bounded, the minimum effort required for the activity to be zero, whereas an overestimation is not naturally bounded. A more likely probability distribution of the effort estimate is one based on gamma reduction. The gamma distribution, look at the probability that goes around it. The estimation probability increases, but over a period of time, the completions, it probability goes down, absolutely down. Now, this is what we are talking about, the gamma distribution, the alpha and the beta, and what has been explained. Look, when the probability is more than zero, the alpha and beta are both real. Now, it goes up very fast, and over a period of time, the generalization, the factorial function comes into play. The assumption error occurs when we make incorrect assumptions. For example, for the estimate of 1000 function points, is based on the assumption that we have incorrectly, or should I say correctly, identified all the customer's requirement. If you can identify the assumption, you can very well determine the risk associated with it. if there is a 10% probability that the requirement complexity has been underestimated, and if it has you estimated another 100 function points will be required, you obtain an estimate risk exposure. Risk exposure is E2 minus E1 times the probability things, wherein E1 is the effort of the original assumption and E2 is the effort of the alternative assumption if it is true, and P2 is the probability that the alternative assumption is being true. Looking for contingency plans altogether, the risk associated or exposure correspond to the contingency you need to protect yourself against the assumption error. The probabilistic nature of the risk means that the contingency will not protect a project if the original assumption is invalid. Risk exposures and model error are independent. If you include uncertainty in the model, then you should not include it in the risk assessment. Do not double count the uncertainty. Do not double count the risk. Risk management should be across entire organization project portfolio. The organization should hold all contingency days in central fund, which can be drawn on by project as on when required. This is similar to the philosophy used by the insurance company. With this, I come to the end of this video. Therefore, I'm signing off, bidding goodbye to all of you.